So now picking up from where we left off, we're going to talk about displacement and velocity as opposed to distance and speed. So displacement and velocity are both vector quantities. Now we learned about vector quantities last time, and then we learned that they have magnitude and direction. That is to say that we have to specify what direction they are pointing in, and the best way to describe that is with arrows. We saw this with forces and displacement, and the same is true for velocity. I'll just demonstrate it with displacement. And if we have this line here, that is displacement. It measures both a distance, it has a magnitude, which is the size, the length of the line, but it also has a direction as well. It's from this point to this point, and that is a very different displacement to one that's moving like to a line like this or a line like that. The distance, for all of them are the same. All of those lines. The distance for all of them is the same because they have the same magnitude. Clearly in the way I've drawn them, that's approximate, but they have the same magnitude, but don't have the same direction. So just to stress that, displacement is distance with direction. So the direction is really important. But just as we saw that speed was basically the change of distance per unit time, we can see that velocity is just the change of displacement per unit time, or speed in a given direction is the logical consequence. And what does that mean? Well, it just means to go back to our running track. For instance, if I draw that here, we saw that for distance, the distance around the track would be 200 meters. And if you ran it, that's the distance you'd cover. But clearly, again, if you started here and finished here, your displacement is 0 meters. I'll do that in green. So your distance is 200 meters, but your displacement is nothing. Because you've come full circle, you haven't changed your position, which is the key thing. You may have moved, but your position hasn't changed. Your position with respect to a particular point, which is what displacement is, that hasn't changed, and therefore your displacement is 0 meters. And so again, just to follow that up, because velocity can change even if speed is constant, because constant velocity means both constant speed and direction, we see that in the example above with the running track, our velocity isn't constant, even though our speed was. If we ran the track at constant speed, our velocity still wouldn't be constant because it's constantly changing. Why is that? Well, if we're running tangent to the circle, that is to say that we're running along it.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.